like I said, I want to spend some time going through this exam. The average was actually pretty good. There's a few that are online. The thing about grading the online ones, it's a little bit annoying because I have to grade them all at once. That is like, I can't do it problem by problem. I have to literally go through an entire exam and then go through another entire exam. I generally don't like doing that, just so I stay consistent per problem. But I should easily be able to finish that this afternoon for sure. So if you find yourself in that boat, rest assured that will be done by today. But I want to go through this nonetheless. Just so the average was like, I don't know, like 84 or something like that, which was, I thought, pretty good for the most part. Yeah, so let's have a look at this. So I sort of had a 0 point, 1 point, or 3 point assignment scheme for the most correct answer, because there were some that were, well, I mean, there was, technically speaking, there was only one correct answer, but some of these answers were more wrong than other answers. Okay, and as such, I sort of had mercy when it came to that in some cases. Now, in this first one, what you basically do is you say, well, tangent of t, let me see here. Let me see if I can do this. What's going on here? Oh, I see, I'm gonna have to sync this pin to the thing again. Okay, here we go. I think it's ready to go now. Yep. Okay, so basically x over 4 is tangent of t, correct? And if I go y minus 1 and I divide by 3, I get secant of t. Okay, and you know that tangent squared plus 1 is equal to secant squared, correct? So tangent squared plus 1, that's the same thing as x squared over 4 squared plus 1. That's tangent squared plus 1 is equal to secant squared, which is y minus 1 quantity squared over 3 squared. Okay, and as you can see, so hang on a second. As you can see, which one is, so hang on, tangent squared plus 1. Did I do that right? Oh, right. Oh, I was freaking out there for a minute. Right, so then I have to subtract over x squared minus 16. So it's this one right here. You see that? Okay, so it's a hyperbola, right? That is the equation of a hyperbola. Okay. All right. So moving down the line here, find the equation of the parabola with focus -1, 2 and directrix x equal to 3. Focus and directrix. Okay. Now, 2 of these you should immediately be able to eliminate because of the way the parabola is oriented. The focus is -1, 2. So here's the focus. The directrix is x equal to 3, which is a vertical line, yes? That tells us that the vertex of this parabola is going to be the point, like that's halfway between those two things. The vertex of this thing is going to be the point 1, 2, okay? And that the parabola is going to basically kind of open this way, okay? So since the parabola kind of opens like this, right, and opens sort of horizontally rather than vertically, that immediately rules out these top 2 things, yes, because those would be y as a function of x. So here we're going to have x as a function of y. And then you immediately say, well, the point 1, 2 is on the parabola, being the vertex. Which of these has 1, 2 on it? Which of those 2 options would permit x equal to 1 and y equal to 2 as a solution? Well, this one, yeah? And what I mean by more correct and less correct, like in this case, I think I gave all 3 points to the correct answer, obviously. I think I gave you 1 if you got this one. Okay, and then I gave you 0 if you did the other 2. Okay, so there's some that were more wrong than others in that case. Okay. Moving on. What is the equation of the tangent line for this parametrized curve? Okay. Well, for this one, you know that dx dt is 3t squared. Okay. And you know that dy dt is 2. Therefore, dy dx is equal to dy dt over dx dt. Yes? We kind of figured that out about parametrized curves. So that's going to be 2 over 3t squared. Okay? And we want to evaluate this thing when t is equal to, what was it, 2? And so what do we get? 2 over 12, which is a 1/6. So we have a slope of 1/6, okay? And what is the point? So this is our slope at that particular t value. What point are we at? So the point is going to be x comma y evaluated at t equal to 2. So what is that point? So what is that point? If I plug in t equal to 2, I get the x coordinate is 8 and the y coordinate is 4. Therefore, what is the equation of the tangent line? Well, first of all, this is just ridiculous. That has a t in it, right? This is ridiculous. The slope is 6. By the way, at this point, you don't even need to know anything, right? All we needed to know was the slope, and we immediately knew what the answer was. Okay, but this one works. X minus 8 times the slope is equal to y minus 4. This is the equation of that line. Okay. Find the symmetric equations of the line with direction vector that and through that point. Okay. Well, you know, look, what I like to do for these here. Let me kind of clear this out just so it's not quite as obnoxious. Let's write it as xyz equal to, you can think of that point as a vector emanating from the origin, and then you take any multiple of the direction vector 2, 3, 2. And from that, you know that you can get the parametric equations, x equal to -2 plus 2t, x equal to -2 plus 2t, y equal to -1 plus 3t. All I'm doing is distributing the t to the direction vector and combining coordinates, okay? And z equal to -1 plus 2t. There it is, okay? And then we get the symmetric equations by solving for t, correct? So I think that's going to give us this guy right here. Okay, because you're going to add 2 and divide by 2. It's going to x plus 2 over 2 equals, all of these things are equal to t. Equals y plus 1 over 3 equals z plus 1 over 2. Okay, so it's this guy right here. Okay. Yeah. The other ones were various jumbled versions of that. Okay, where you maybe accidentally use the direction vector as the point instead of the point itself, for instance. Okay. So what about this? Which of the following polar coordinates correspond to the rectangular coordinate given by that? Well, this one was fairly straightforward. You actually didn't even need to know what you're doing other than the fact that this point right here, what quadrant does 2 radical 3 comma 2 live in? Well, that's in the first quadrant, right? And then you say to yourself, is this first point in the first quadrant? Radius of 4 Angle 5, no. Okay. Is this point, is 4 negative pi over 6, is that in the first quadrant? No. That's in quadrant, right? So this first point over here, that was in quadrant 2. This is in quadrant, what quadrant is this guy in? 4. Okay. Pi over 6, negative 4. Pi over 6 gets us in the first quadrant, then negative 4 flips us over into the third quadrant. All right, so that's in quadrant 3, so that's no good. So you know it has to be this one, okay, and it is. 7 pi over 6, that's in quadrant 3, but then the negative 4 flips us back to quadrant 1, so it's this one right here. Okay? Interesting. Okay. Any questions on that first page? Any questions on that first page? Well, okay. So calculate the area inside of one leaf of the 4 leafed rows given by that. Some of you kind of drew the wrong picture, but then bailed yourself out somehow. But the picture for this actually looks this way. It goes like this. Okay. And like this first petal gets traced for 0 equal to or less than theta equal to or less than pi over 2. Okay. So if I want the area inside of this, okay, let me just, let me call that A. If I want the area inside of this first petal, A is going to be, now remember, there's like a 1/2 out front, yeah? It's going to be the integral from 0 to pi over 2, and it's going to be r squared d theta. That was what the formula was for area inside of a polar region. Okay, so this is 1/2 integral from 0 to pi over 2. I have to square this. I have to square 2 sine 2 theta. So that's going to be 4 sine squared of 2 theta d theta. Okay, which is 4 over 2 is just 2. And then what you can do is you can actually use, I even gave you the formula right here for the half angle identity, yeah? So what you can do is you can plug in that, and that's going to kick out a factor of 1/2. It's going to be the integral from 0 to pi over 2. Now be careful, sine squared of t is equal to that. So sine squared of 2t is going to be 1/2 1 minus cosine of how many t? Or theta, I guess, in this case. 4 theta. That's important. And so it's going to be 1 minus cosine of 4 theta d theta. Okay. These guys cancel 2 and 1/2, right? So this, this cancels with this. We're good to go there. And then this is just going to be theta minus 1/4 sine of 4 theta, all evaluated between 0 and pi over 2. Okay, if I plug in pi over 2 and 0 into the sine thing, that's just going to be 0 both times. If I plug in pi over 2 and 0 into the first thing, I end up getting pi over 2. Okay, if I plug that in for theta. Okay, so the area is pi over 2. Okay? Any questions on that? Questions? Yeah, Trent.
What was the formula where instead we would take it from the same area and we would do the dx dt squared plus dy dt squared, that quantity square root?
That's the square root of dx dt squared plus dy dt squared. That was the formula for arc length. That was not the formula for area. Does that make sense? Yeah. Okay. So let's see here. Any questions on that? Any other questions? All right, moving on. Determine whether these two lines are parallel, intersecting, or skew. All right, well, okay, so let's give names to these lines, shall we? So let's call this one L1, and let's call this line right here L2, okay? So a point on L1 would be P1 equal to, the most obvious point is to just make everything 0. So like -2, 2, 8 would be a point on the first line. On the second line, 2, 3, 5, make every one of those 0, yeah? Now a direction vector for the first line is gotten at by looking at the denominators of these things. And some of you forgot that it's not a 0 down here, it's a 1, yes? Okay, and there's a 1 right here. So the direction vector for the first line, or a direction vector, would be 4, 1, -3. A direction vector for the second line is 1, -3, 2. And you stare at that for a minute, and you realize that V1 and V2 are not parallel. Does that make sense? There's nothing you can multiply the first direction vector by to get the second one, or vice versa, yes? So V1 does not equal to some constant times V2, so L1 and L2 are what? Are not parallel. Okay, so that's the first thing that you can say about this. Secondarily, you say, well, if I were to write the parametric equations of the first line and the second line, I can do that fairly easily at this point. So it would be x equal to -2 plus 4t, y equal to 2 plus t, and z equal to 8 minus 3t, right? So that's the parametric equations for the first line. For the second line, what do we have? Well, x equal to 2 plus s. I'm using a different parameter for the second line. Remember that trick? You don't want the 2 points to have to move together on the 2 lines. You want them to move independently of each other so you can determine if they actually intersect, yeah? So I'm using a different parameter for the second one. So x equals 2 plus 1s, y equals 3 minus 3s, and z equals 5 plus 2s. Okay, interesting. And then what you do is you basically, you say, well, what if I set the x coordinates equal, for instance? If I set the x coordinates equal, I would get -2 plus 4t equals 2 plus s, okay? And if I set the y coordinates equal, I get 2 plus t equals 3 minus 3s. And then what am I going to do? To see if there is a point of intersection, I'm going to solve for t and s. And see, and by the way, that will make x and y the same. It will work, okay? But the issue is, does it also make z the same? And if it doesn't, then that means these lines are skew, not intersecting, okay? I guess, so let me see here. I don't know. If I take this second guy right here, let me see, let me use black here. I take this second guy right here and I solve for t, I get that t equals, if I subtract 2 to the other side, I get t equals 1 minus 3s. Okay? And then what I can do is I can take t equal to 1 minus 3s, I guess, and I could put that right there. Know what I mean? Yep. And if I do that, I get, what do I get? -2 plus 4 times 1 minus 3s equals 2 plus s. Okay. Distribute. I get -2 plus 4 minus 12s equals 2 plus s. Okay, getting closer, I guess. 4 minus 2 is 2. Doesn't that cancel with this 2 on the other side? That's amazing. That's interesting. So these guys just cancel, yeah? And if I add 12s to that side, what I end up getting is that 13s equals 0. So what does that tell us s has to be? S is 0. But if s is 0, I don't know, I could put that right there. And what do I get that t would have to be? 1. Okay? So s is 0 and t is 1. So if I plug t equal to 1 into the first line, what point do I get? If I plug t equal to 1, I get x equal to, if I plug t equal to 1, it's going to be -2 plus 4, which is 2. Y equal to 3. Remember, t is 1. Okay, and z equal to 5. Right? And if I do the same thing over here, right, so I get 2, 3, 5 is my point. Okay? If I do the same thing over here, if I plug in s equal to 0, right, if I plug in s equal to 0 into this line, what do I get? X equal to 2, y equal to 3, and z equal to 5. Amazing. So I get the point 2, 3, 5. So what do we conclude? The lines intersect at the point 2, 3, 5. Yeah? It actually worked out perfectly that time. Okay? Any questions on that? Questions? Okay. Yes. Find a Maclaurin series expansion and the radius of convergence for the following function. Okay, so one thing I would point out is this nice little formula that we know. 1 over 1 minus x equals 1 plus x squared plus etc. Okay, and that is good for x in absolute value less than 1, right? So 1 over 1 plus x, we did this one as well, right? 1 over 1 plus x, you just replace x with minus x in the previous guy, and you end up with 1 minus x plus x squared minus x cubed plus etc. And that's still good to go for x in absolute value less than 1. Now, how could I use that information here? Well, I can factor out 4/3. And if I factor out 4 in the top and 3 in the bottom, this is going to give me 1 over 1 plus 7x over 3. Do you see what I'm saying? And does that not just look almost exactly like this down here, except x has been replaced by what? What's x been replaced by? 7x over 3, right? So this thing is going to be equal to, look, I just leave this constant where it is. It's going to be 1 minus 7 over 3x plus 7 squared over 3 squared x squared minus etc. Okay. And where is this good for? Where is this good to go? Before it was x in absolute value less than 1, but what's playing the role of x? 7/3 x. Right, so this is going to be 7 over 3x less than 1, which means x in absolute value is less than 3/7. That, my friends, is the radius of convergence. Right, so that's the radius of convergence. Okay? That is the radius of convergence. Yeah.
Would you mark off if it
would I mark off if it was, well, no, I was pretty,
7/3 x less than 1.
no, I mean, I was pretty generous on that. Yeah, I mean, some people even like, some people like took like derivatives and found a pattern, okay, which made it pretty gnarly. Because you had like tons of factorials and they didn't realize that all of those factorials were just canceling, okay? But anyways, so there's that radius of convergence, yeah? Okay. Now here's the thing, before I even go down to the next problem, what would happen if I integrated this thing? So like, if I were to integrate, so let me just use red here. What if I were to integrate f of x dx? What would I get? Think about it. What is the antiderivative of 4 over 3 plus 7x? 4, okay, so 4 times, or actually it's 4/7 times the natural log of what? 3 plus 7x. Right? Plus some kind of constant or something. Yeah? Does that make sense? Yeah? Why is that relevant? So the next problem. Okay, so we'll go down there in just a minute and we'll sort of see why, but basically that just means that we can get the next thing by simply integrating this thing. Yes? I mean, it's like messed up by a constant, but who cares? We can fix all of that for sure. Okay. So here, let me kind of write this. I'll go down to the next line and we'll mess with this thing. Okay, so remember from the previous part, f of x was equal to 4/3 1 minus 7/3 x plus 7 squared over 3 squared x squared minus etc. And that was good to go for x in absolute value less than 3/7. That was the radius of convergence. We said that the integral of f of x dx is equal to some kind of constant, right? After all, so what was f of x again, just to make sure we're on the same page? F of x was 4 over what? 3 plus 7x, that's exactly right, okay? So the integral of this is 4/7 natural logarithm of 3 plus 7x plus some kind of constant, yeah? Okay, that doesn't quite look like what we wanted. It's off by a little bit. There should be a 6 there, not a 4/7, yes? You see what I mean? Okay, so how can I fix that? Well, you know, I can say, well, this is going to be 4/7. So I multiply 4/7 by 6 and I divide it by 6. Okay. And so I go 4/7 or 4 over 42 times 6 natural log of 3 plus 7x plus a constant. Okay. And then all I have to do is just integrate this thing term by term. So let's see here. I can integrate that thing term by term. Okay. What is the antiderivative of 1? By the way, the 4/3 just kind of comes along for the ride. 4/3. Okay, what's the antiderivative of 1? What's the antiderivative of 1? X. Okay, and then what about the next thing? Minus 7/3 times x squared over 2, yes? What's the next thing? Minus, or sorry, plus 7 squared over 3 squared times what? X cubed over 3 minus etc. Okay, so basically we just integrate that thing, and that thing is going to be equal to, what do I have here? 4 over 42 times 6, natural logarithm of 3 plus 7x plus a constant. Okay. I can multiply through by 42 over 4. And if I multiply both sides by 42 over 4, okay, the 4s are just going to cancel in the 4/3, and I get 42 over 3, which isn't that about 14 or something like that? Yeah. I'm going to get 14 times this nonsense, x minus 7/3, x squared over 2 plus 7 squared over 3 squared, x cubed over 3, minus etc. By the way, I'm just going to move the constant to the other side. It doesn't even matter if it's a plus or a minus. We'll have to sort out what this thing is later. Okay, so this is going to be equal to 6 natural logarithm 3 plus 7x. And by the way, what is the radius of convergence? All we did was integrate the previous thing. What's the radius of convergence for this thing? It's the same. Remember talking about that? The radius stays the same if we integrate or differentiate. Okay, so the radius of convergence is still 3/7. We're still allowed to plug anything in between -3/7 and 3/7, not necessarily including the endpoints. How do I figure out what this constant is right here? What would I do to sort out what that constant is? What do I do to figure that out? Plug in x equal to 0. Do you know what I'm saying? Yeah? If I plug in x equal to 0, it's going to kill all the x stuff on the left. Yeah, and I'll just have the constant left. And you end up getting that c equals what? What's c going to be equal to? 6 natural logarithm of 3. Yeah? So there it is. You didn't have to do it that way, but that way you didn't have to reinvent the wheel or anything like that. You could have also memorized what the power series was for logarithm. Okay. Any questions on that? Yeah.
When you took f of x and put it down equal to the integral f of x, where did the x squared over 2 come? Because like you don't have x squared over 2 in the top f of x, but you have x squared over 2 in the bottom.
Well, because we integrated.
Yeah. Oh, okay. I see now.
So we integrated this thing to try to turn it into make it look like that logarithm. Does that make sense? Okay. Again, not the only way to do that problem, but one way to do it. Yeah. All right. Any other questions on that? So the radius of convergence is once again 3/7 because it was connected to the other one. Right. Another way to do this, by the way, would have been to, so let me just say, would have been to go like this. You say that this is 6 times the natural log of, oh boy, 3 plus, oh, no, what am I writing here? 3 times 1 plus 7x over 3. Okay. And then what you do is you say this is like 6 times logarithm of 3 plus logarithm of 1 plus 7x over 3. I just use the laws of logarithms where it's the logarithm of a product is the sum of logarithms. And then basically what you have here is this is going to be 6 logarithm of 3 plus 6 logarithm of 1 plus 7x over 3. And then you could basically use the formula for logarithm of 1 plus t or whatever it is. Remember, we had a formula for that, if you will recall. Okay. And there you see that little constant kind of popping out right there again. Okay. So that would have been another way to proceed. Any questions on that? Okay. Equation of a plane containing those points. Well, okay, so we had a nice plane like this. So the point 2, so here's 2, here's the point 3 on the y-axis and the point 4 on the z-axis. Okay, so these 3 points are on the plane. Okay, so this is, here's our plane right here. Okay, and we want to come up with a the equation of this plane. So what I suggest doing, and a lot of you did this, is you kind of form vectors like this along these little lines. So I don't know, let's call this vector right here A, and let's call this B, all right? What is that vector A? So it goes from 2, 0, 0 to 0, 0, 4. So how much change has there been in the x direction and moving from the beginning point of A to the terminal point of A? How much movement has there been in the x direction? -2. How much movement in the y direction? 0. How much movement in the z direction? 4. Okay, what about B? Well, -2 in the x direction, 3 in the y direction, 0 in the z direction. And then I could take my normal vector to just be A crossed with B, right? That would give me a vector perpendicular to this plane. So if I cross these things, what do I end up with? Well, you remember what we do is we kind of cross out the first column, okay, and then we look at this, okay? So that's going to be like -12, right? So, because it's going to be 0 minus 3 times 4, which is -12, comma, okay? Let me see here, I'll erase this, and all this junk here. Okay, so what comes next? Well, I cross off the middle guy, and I negate. What happens if I do -2 times 0 minus -8? So minus -8 is +8. Okay, so that's -8 is that guy. And then finally, if I cross out the last column, it's just -6. Okay, so the normal vector is, or a normal vector is -12, -8, -6. Okay. So then what you do is you say -12 times x minus something minus 8 times y minus something minus 6 times z minus something equals 0, where those somethings are an x, y, and z coordinate of a point on the plane. Well, I don't know, you could pick any point you want, but an obvious one is the point 2, 0, 0, I guess, yeah? So you could put 2, 0, 0 in here. And you could simplify this if you want. You get like, I don't know, -12x minus 8y minus 6z plus 24 equals 0. Okay? And you can multiply by negatives and divide by 2 if you really want to, but this is definitely sufficient. Okay, right there. Okay, so there's the equation of the plane. Okay. All right, and then I asked you something about distance between a point and the plane. And we had a nice formula for that. Any questions on that before we get down to that? Any questions? Okay. You would determine the distance from the origin to the plane from the last part. Okay, well, remember the equation of the plane was -12x minus 8y minus 6z plus 24 equals 0. So of course our normal vector was negative 12, negative 8, negative 6. I want the distance from the plane to the origin. The distance from the plane to the origin. Okay, so first of all, let me redraw this thing. Okay, so this was 2 and then 3 in this direction and 4 in this direction. Okay. And I want the distance. Yeah, man, I'm just having to redraw this thing, unfortunately. Okay, and then I have this point here at the origin that I'm concerned with. Okay, and the way that we did that, if you'll recall, is we actually formed a vector from a point to that point. Okay, so let me, if I call that point Q right there, and of course this point was the point A from the previous part, and we formed the vector from A to Q, all right? Okay, so what is the vector AQ? Negative 2, 0, 0. And then remember, the distance formula said what you should do is take the absolute value of the dot product of this within, and you should divide it by the length of n. That we did a little bit of trigonometry to determine that. Okay, there was some nice trigonometry, right triangle trigonometry that gave that formula to us. Well, the dot product of those two things fairly easy. Think about it. So look at these two vectors right here. If I take the dot product, well, AQ has a couple of 0 coordinates. That's just going to be negative 2 times 12, negative 12, which is 24, yeah? It's going to be 24 over the square root of, I have to square each one of these coordinates, 144 plus 64 plus 36, right? So that's 24 over the square root of 244. And if you really wanted to simplify this, you could, write that as 4 times 61 and cancel the square root of 4, which is 2. So you have 12 over the square root of 61. That is the distance. Okay? 12 over the square root of 61. Yeah. And that's it. That's the test. I do want to say a couple of things. I think that it's like a settled thing that for sure we're going to have a take-home final for sure. I just have way too many people in quarantine right now. So I'm going to distribute that tomorrow. Okay, I want to spend some time, a little bit more time talking about series tomorrow. Since we just went through this test, hopefully that was fairly a fairly substantive review of some of the more recent topics, but I want to spend time on series in particular tomorrow. Okay? Any other questions? Yeah, Jared. We can't meet on Thursday because you apparently might have finals in other classes, but we will meet on Friday just to wrap some stuff up. Yeah.
So are we done with like the lesson aspect?
Yeah, with content, yes, we're done. Yes, that's right. So 12.3 is the last section. Yeah, David. You would turn it on like next Wednesday, probably by like noon or something like that. But I mean, you could turn it in earlier if you want to, of course, but that's when it would be due.
Just like to your office.
Yep. Anything else? You can turn it in my office. Yeah.
Where's your office?
You can see that on the syllabus. It's like if you go.
You can also just look at slides and then get the address and probably find it.
Yeah, so like if you just go to the course page, of course it's, my office is listed somewhere on here. Where is it? Right, ENS 371 right there. Okay. All right. That's it.